Hello everyone. Data-related IT jobs have different roles. Starting with Data Engineer. Role of a data engineer. Responsibilities. Data pipeline development. Design, construct, and maintain scalable data pipelines that ingest, transform, and deliver data. Ensure data flow is smooth and efficient from various sources to destinations like data warehouses or data lakes. Data integration. Combine data from different sources, ensuring it is clean, consistent, and usable. Work with ETL, extract, transform, load, tools to automate data extraction, transformation, and loading processes. Data warehousing. Design and manage data warehouses or data lakes to store large volumes of data. Optimize data storage and retrieval for performance and cost efficiency. Data quality and governance. Implement measures to ensure data quality, accuracy, and reliability. Monitor data processes to detect and resolve any issues or discrepancies. Collaboration. Work closely with data scientists, data analysts, and other stakeholders to understand data requirements. Collaborate with software engineers and DevOps teams to integrate data solutions with other systems. Performance optimization. Optimize data systems for performance and scalability. Tune databases and queries to ensure efficient data processing. Key skills. Programming languages. Proficiency in SQL for querying and managing databases. Knowledge of programming languages such as Python, Java, or Scala for data processing and pipeline development. ETL tools. Experience with ETL tools like Apache NiFi, Tailend, or Informatica. Familiarity with open-source frameworks like Apache Airflow for orchestrating workflows. Big data technologies. Knowledge of big data technologies such as Hadoop, Apache Spark, and Kafka. Experience with distributed data storage systems like HDFS, Hadoop Distributed File System, or cloud-based solutions like AWS S3. Databases. Experience with relational databases, example MySQL, PostgreSQL, and NoSQL databases, example MongoDB, Cassandra. Understanding of data warehousing solutions like Amazon Redshift, Google BigQuery, or Snowflake. Cloud platforms. Familiarity with cloud platforms, example AWS, Azure, Google Cloud, for deploying and managing data infrastructure. Understanding of cloud services related to data storage, processing, and analytics. Data modeling. Ability to design and implement data models that support business requirements. Knowledge of different data modeling techniques and best practices. Data governance and security. Understanding of data governance principles to ensure compliance and data protection. Implementing security measures to safeguard data integrity and privacy. Typical tools and technologies. ETL/L tools, Apache Airflow, Tailend, Informatica, Apache NiFi. Big Data Technologies, Hadoop, Apache Spark, Kafka. Databases, MySQL, PostgreSQL, MongoDB, Cassandra. Data warehousing, Amazon Redshift, Google BigQuery, Snowflake. Cloud platforms, AWS, Azure, Google Cloud. Programming languages, SQL, Python, Java, Scala. Data orchestration, Apache Airflow, Luigi. Example workflow. Data ingestion. Collect data from various sources such as APIs, databases, and files. Use tools like Apache Kafka for real-time data ingestion or batch processing tools for scheduled data collection. Data transformation. Clean and transform data to meet analytical requirements. Use ETL tools to automate transformation processes, ensuring data quality and consistency. Data storage. Store transformed data in a data warehouse or data lake. Optimize storage for performance, ensuring quick access for analysis and reporting. Data access and analysis. Provide access to data for data scientists, analysts, and other stakeholders. Ensure data is accessible via SQL queries, APIs, or other data access methods. Monitoring and maintenance. Continuously monitor data pipelines and storage systems for performance and reliability. Address any issues promptly to ensure smooth operation. Career path. Entry level. Start as a junior data engineer or data engineering intern. Gain hands-on experience with data pipelines, ETL processes, and basic database management. Mid-level. Progress to a data engineer role, taking on more complex projects and responsibilities. Lead the design and implementation of data architectures and pipelines. Senior level. Advance to a senior data engineer or lead data engineer position. Oversee large-scale data projects, mentor junior engineers, and contribute to strategic decisions. Specialization. Specialize in areas like big data engineering, cloud data engineering, or data architecture. Develop expertise in specific technologies or industry domains. Management. Move into managerial roles such as data engineering manager or director of data engineering. Lead teams of data engineers and drive data strategy for the organization. Then next. Data analyst. Role of a data analyst. Responsibilities. Data collection and cleaning. Gather data from various sources like databases, APIs, and spreadsheets. Clean and pre-process data to ensure its accuracy and readiness for analysis. Data analysis. Analyze data to uncover patterns, trends, and insights. Use statistical methods and tools to interpret data and draw meaningful conclusions. Reporting and visualization. Create reports, dashboards, and visualizations to present data insights. Use tools like Tableau, Power BI, or Excel to make data accessible and understandable for stakeholders. Business insights. Translate data findings into actionable business insights. Communicate results to stakeholders, helping them make informed decisions. Performance tracking. Monitor and analyze key performance indicators, KPIs, to track business performance. Identify areas for improvement and provide recommendations. Collaboration. Work closely with other teams, such as marketing, sales, and product, to understand their data needs. Collaborate with data engineers to ensure data quality and availability. Key skills. Data analysis. Proficiency in SQL for querying databases. Ability to perform data manipulation and analysis using tools like Excel, Python, or R. Data visualization. Expertise in creating visualizations using Tableau, Power BI, or similar tools. Understanding of data visualization principles to effectively communicate insights. Statistical analysis. Knowledge of statistical methods and techniques. Ability to apply statistical analysis to interpret data and draw conclusions. Business acumen. Understanding of business processes and objectives. Ability to translate data insights into business recommendations. Communication. Strong verbal and written communication skills. Ability to present complex data findings in a clear and concise manner. Problem solving. Analytical thinking and problem solving skills. Ability to identify data-related issues and develop solutions. Typical tools and technologies. SQL, for querying and managing databases. Data visualization tools, Tableau, Power BI, ClickView. Spreadsheet software, Excel, Google Sheets. Programming languages, Python, R for advanced data analysis. Statistical software, SAS, SPSS. BI tools, Looker, Domo. Example workflow. Data collection. Gather data from various sources like databases, CRM systems, and external data providers. Ensure data is up to date and relevant to the analysis. Data cleaning. Remove duplicates, handle missing values, and standardize data formats. Ensure data is accurate and consistent for analysis. Exploratory data analysis, EDA. Perform initial analysis to understand data characteristics and distributions. Identify trends, outliers, and patterns in the data. Data visualization. Create visualizations to represent data insights. Use charts, graphs, and dashboards to make data easy to interpret. Reporting. Compile analysis results into reports. Present findings to stakeholders through presentations or written reports. Performance monitoring. Track KPIs and metrics over time. Provide regular updates to stakeholders on business performance. Career path. Entry level. Start as a junior data analyst or data analyst intern. Gain experience in data analysis, reporting, and visualization. Mid-level. Progress to a data analyst role with more responsibility and complex projects. Lead analysis projects and collaborate with other teams. Senior level. Advance to a senior data analyst or lead data analyst position. Mentor junior analysts and take on strategic projects. Specialization. Specialize in areas like marketing analytics, financial analysis, or product analytics. Develop expertise in specific industries or data analysis techniques. Management. Move into managerial roles such as analytics manager or director of analytics. Lead teams of analysts and drive data strategy for the organization. Then next. Data scientist. Role of a data scientist. Responsibilities. Data collection and cleaning. Gather data from diverse sources, including databases, APIs, and external data sets. Clean, pre-process, and structure data to ensure its quality and suitability for analysis. Exploratory data analysis, EDA. Perform initial investigations on data to discover patterns, spot anomalies, and check assumptions. Use statistical methods and visualization tools to understand data characteristics. Model building. Develop predictive models using machine learning algorithms. Select appropriate models based on the problem, such as regression, classification, clustering, or recommendation systems. Model evaluation and tuning. Assess model performance using metrics like accuracy, precision, recall, F1 score, ROC AUC, etc. Tune models to improve performance through hyperparameter optimization. Deployment and monitoring. Deploy models into production environments. Monitor and maintain models to ensure they perform well over time and adapt to new data. Data visualization and reporting. Visualize model outputs and data insights. Communicate findings and recommendations to stakeholders through reports, presentations, or dashboards. Research and development. Stay updated with the latest developments in machine learning and data science. Experiment with new algorithms, tools, and techniques to improve data science capabilities. Key skills. Programming languages. Proficiency in Python and / R for data analysis and modeling. Familiarity with other languages like SQL for data manipulation. Machine learning. Understanding of machine learning algorithms and frameworks such as scikit-learn, TensorFlow, Keras, and PyTorch. Ability to select and implement appropriate algorithms for various tasks. Statistics and mathematics. Strong foundation in statistics, probability, and linear algebra. Ability to apply statistical methods to analyze data and validate models. Data visualization. Expertise in creating visualizations using tools like Matplotlib, Seaborn, Plotly, or Tableau. Ability to convey complex data insights in a clear and understandable manner. Big data technologies. Familiarity with big data tools like Hadoop, Spark, and distributed computing frameworks. Ability to handle and process large data sets efficiently. Domain knowledge. Understanding of the specific industry or domain in which the data science work is being applied. Ability to translate business problems into data science problems and solutions. Typical tools and technologies. Programming languages, Python, R, SQL. Machine learning frameworks, scikit-learn, TensorFlow, Keras, PyTorch. Data manipulation, Pandas, NumPy. Data visualization, Matplotlib, Seaborn, Plotly, Tableau. Big data tools, Hadoop, Spark, Hive. Cloud platforms, AWS, Azure, Google Cloud. Version control, Git, GitHub. Example workflow. Problem definition. Understand the business problem and define the data science objectives. Collaborate with stakeholders to gather requirements and set expectations. Data collection. Identify and collect data from relevant sources. Ensure data is representative of the problem and sufficient for modeling. Data cleaning and pre-processing. Handle missing values, outliers, and inconsistencies in the data. Normalize, transform, and engineer features to prepare data for modeling. Exploratory data analysis, EDA. Analyze data distributions, correlations, and patterns. Visualize data to gain insights and guide model selection. Model building. Choose appropriate machine learning algorithms based on the problem. Train models on the prepared data and validate their performance. Model evaluation. Evaluate models using appropriate metrics and cross-validation techniques. Compare model performance and select the best model. Model deployment. Deploy the model into a production environment. Integrate the model with existing systems or create APIs for accessibility. Monitoring and maintenance. Continuously monitor model performance and update it as needed. Address data drift, model degradation, and other issues over time. Career path. Entry level. Start as a junior data scientist or data science intern. Gain experience in data analysis, machine learning, and model deployment. Mid-level. Progress to a data scientist role, taking on more complex projects and responsibilities. Lead data science initiatives and collaborate with cross-functional teams. Senior level. Advance to a senior data scientist or lead data scientist position. Mentor junior data scientists and drive strategic data science projects. Specialization. Specialize in areas like natural language processing, NLP, computer vision, or deep learning. Develop expertise in specific industries or advanced data science techniques. Management. Move into managerial roles such as data science manager or director of data science. Lead teams of data scientists and drive data strategy for the organization. Then next, database administrator, DBA. Role of a database administrator, DBA. Responsibilities: database installation and configuration. Install and configure database management systems, DBMS, like MySQL, PostgreSQL, Oracle, or SQL Server. Ensure databases are set up according to best practices and organizational requirements. Database maintenance. Perform regular maintenance tasks such as backups, recovery, and updates. Monitor database performance and make necessary adjustments to optimize efficiency. Data security. Implement security measures to protect data from unauthorized access, breaches, and other vulnerabilities. Manage user access and permissions to ensure data integrity and security. Performance tuning. Analyze and optimize database performance through indexing, query optimization, and hardware enhancements. Monitor system performance metrics and resolve performance issues. Data backup and recovery. Develop and implement backup and recovery strategies to prevent data loss. Perform regular backups and test recovery processes to ensure data can be restored in case of failure. Database design. Design and model database structures that meet the needs of the organization. Ensure database schemas are scalable and maintainable. Capacity planning. Plan for future database capacity requirements based on organizational growth and data usage trends. Ensure databases can handle increasing volumes of data without performance degradation. Troubleshooting. Diagnose and resolve database-related issues, including performance problems, connectivity issues, and data corruption. Provide support to developers and users for database-related queries and issues. Key skills. Database Management Systems, DBMS. Proficiency in DBMS such as MySQL, PostgreSQL, Oracle, SQL Server, and others. Understanding of the strengths and limitations of different DBMS. SQL. Strong SQL skills for querying, managing, and optimizing databases. Knowledge of advanced SQL features and functions. Performance tuning. Experience with database performance tuning techniques such as indexing, query optimization, and caching. Ability to analyze performance metrics and identify bottlenecks. Backup and recovery. Knowledge of backup and recovery strategies and tools. Experience in setting up and testing backup and recovery procedures. Security. Understanding of database security principles and best practices. Experience with encryption, user access control, and vulnerability assessments. Scripting and automation. Proficiency in scripting languages like Python, Bash, or PowerShell for automating database tasks. Ability to write scripts to automate maintenance, monitoring, and backup tasks. Problem solving. Strong analytical and problem-solving skills for diagnosing and resolving database issues. Ability to troubleshoot complex problems and provide effective solutions. Typical tools and technologies. DBMS, MySQL, PostgreSQL, Oracle, SQL Server, MongoDB, Cassandra. Backup tools, RMAN, Oracle, PG_dump, PostgreSQL, MySQLdump, MySQL, native backup tools. Performance monitoring, SolarWinds, Nagios, New Relic, native DBMS monitoring tools. Scripting languages, Python, Bash, PowerShell. Security tools, database auditing tools, encryption tools, access control tools. Version control, Git, GitHub. Example workflow. Database setup. Install and configure the DBMS. Set up initial database structures, user accounts, and permissions. Data migration. Migrate data from existing databases or external sources. Ensure data integrity and consistency during the migration process. Backup configuration. Set up regular backup schedules and procedures. Test backup and recovery processes to ensure data can be restored reliably. Performance monitoring. Monitor database performance using monitoring tools and native DBMS features. Analyze performance metrics and optimize database configurations and queries. Security management. Implement security measures to protect data. Manage user access and permissions to ensure only authorized users have access to sensitive data. Capacity planning. Assess current and future data storage requirements. Plan for database scaling to handle increasing data volumes and user load. Troubleshooting and support. Provide support for database-related issues. Diagnose and resolve performance problems, connectivity issues, and other database errors. Career path. Entry level. Start as a junior DBA or database support engineer. Gain hands-on experience with database administration tasks and tools. Mid-level. Progress to a DBA role with more responsibilities and complex projects. Manage larger databases and take on more significant optimization and tuning tasks. Senior level. Advance to a senior DBA or lead DBA position. Oversee database architecture, strategy, and large-scale database projects. Specialization. Specialize in specific DBMS, example Oracle DBA, SQL Server DBA, or focus on areas like database security or performance tuning. Develop deep expertise in chosen areas of specialization. Management. Move into managerial roles such as Database Administration Manager or Director of Database Services. Lead teams of DBAs and drive database strategy and initiatives for the organization. Then next. Business Intelligence, by Developer. Role of a Business Intelligence, by Developer. Responsibilities. Data integration. Collect and integrate data from various sources into a centralized data warehouse or data mart. Ensure data is clean, accurate, and accessible for analysis. Data modeling. Design and implement data models that support reporting and analytics. Create schemas, tables, and relationships that efficiently store and organize data. ETL processes. Develop and manage ETL, extract, transform, load, processes to move data from source systems to the data warehouse. Ensure ETL processes are efficient, reliable, and scalable. Report and dashboard development. Create reports, dashboards, and data visualizations that provide insights to business stakeholders. Use BI tools like Tableau, Power BI, or Looker to develop interactive and user-friendly visualizations. Performance optimization. Optimize queries and data models to improve report performance and reduce load times. Ensure BI solutions are efficient and can handle large data sets. Collaboration with stakeholders. Work closely with business users to understand their reporting and analytics needs. Translate business requirements into technical specifications and BI solutions. Data governance and security. Implement data governance practices to ensure data quality and consistency. Manage access control and security to protect sensitive data. Key skills. SQL. Proficiency in SQL for querying, transforming, and managing data. Ability to write complex queries and optimize them for performance. BI tools. Expertise in BI tools such as Tableau, Power BI, Looker, ClickView, or similar. Experience in creating interactive reports and dashboards. Data warehousing. Knowledge of data warehousing concepts and architectures. Experience with data warehousing platforms like Amazon Redshift, Google BigQuery, or Snowflake. ETL processes. Experience with ETL tools and processes. Ability to design, implement, and maintain robust ETL pipelines. Data modeling. Strong understanding of data modeling techniques and best practices. Ability to design efficient and scalable data models. Data visualization. Skills in data visualization principles and techniques. Ability to create clear and compelling visual representations of data. Communication. Strong verbal and written communication skills. Ability to explain technical concepts to non-technical stakeholders. Typical tools and technologies. BI tools, Tableau, Power BI, Looker, ClickView. ETL tools, Apache NiFi, Tailend, Informatica, SSIS. Data warehousing, Amazon Redshift, Google BigQuery, Snowflake. Databases, MySQL, PostgreSQL, SQL Server, Oracle. Programming languages, SQL, Python, R. Data modeling tools, Irwin, Lucidchart, Microsoft Visio. Example workflow. Requirement gathering. Meet with business stakeholders to understand their data and reporting needs. Document requirements and translate them into technical specifications. Data integration and modeling. Integrate data from various sources into the data warehouse. Design data models that support the required reports and dashboards. ETL development. Develop ETL processes to extract, transform, and load data into the data warehouse. Ensure ETL processes are automated and optimized for performance. Report and dashboard development. Create reports and dashboards using BI tools. Design interactive and user-friendly visualizations that meet stakeholder needs. Testing and validation. Test BI solutions to ensure they meet requirements and perform as expected. Validate data accuracy and consistency. Deployment and training. Deploy BI solutions to production environments. Provide training and support to business users to help them use the BI tools effectively. Maintenance and optimization. Monitor BI solutions for performance and data accuracy. Make necessary updates and optimizations to improve performance and meet changing business needs. Career path. Entry level. Start as a junior BI developer or BI analyst. Gain experience in data integration, reporting, and using BI tools. Mid-level. Progress to a BI developer role with more responsibilities. Lead BI projects and work closely with business stakeholders. Senior level. Advance to a senior BI developer or lead BI developer position. Oversee the design and implementation of complex BI solutions and mentor junior developers. Specialization. Specialize in specific BI tools, data warehousing platforms, or industries. Develop deep expertise in chosen areas and become a subject matter expert. Management. Move into managerial roles such as BI manager or director of business intelligence. Lead BI teams and drive BI strategy and initiatives for the organization. Then next. Data architect. Role of a data architect. Responsibilities. Data strategy and architecture. Develop and implement an enterprise data strategy that aligns with business goals. Design and manage the overall data architecture, including databases, data warehouses, data lakes, and data integration solutions. Data modeling. Create conceptual, logical, and physical data models that support business processes. Ensure data models are scalable, maintainable, and meet performance requirements. Data integration. Design and implement data integration solutions to consolidate data from various sources. Ensure data is seamlessly integrated and accessible across the organization. Data governance and quality. Establish data governance frameworks and policies to ensure data quality and consistency. Implement data quality measures and monitor data integrity. Technology evaluation and selection. Evaluate and select appropriate data technologies and tools. Stay updated with the latest advancements in data architecture and recommend best practices. Collaboration and communication. Work closely with stakeholders, including business leaders, data engineers, and data scientists, to understand data requirements and design solutions. Communicate data architecture and strategy to technical and non-technical audiences. Security and compliance. Implement data security measures to protect sensitive information. Ensure data architecture complies with relevant regulations and standards. Key skills. Data modeling. Expertise in creating conceptual, logical, and physical data models. Understanding of different data modeling techniques and methodologies. Database management systems, DBMS. Proficiency in relational and non-relational databases, such as SQL Server, Oracle, MySQL, MongoDB, and Cassandra. Knowledge of data warehousing solutions like Amazon Redshift, Google BigQuery, and Snowflake. Data integration. Experience with ETL tools and data integration platforms, such as Apache NiFi, Tailend, Informatica, and SSIS. Ability to design and implement efficient data integration pipelines. Big data technologies. Familiarity with big data technologies like Hadoop, Spark, and Kafka. Experience with data lake architectures and large-scale data processing. Data governance. Understanding of data governance principles and best practices. Experience implementing data governance frameworks and policies. Cloud platforms. Knowledge of cloud data services and platforms, such as AWS, Azure, and Google Cloud. Ability to design cloud-based data architectures. Analytical and problem-solving skills. Strong analytical and problem-solving skills for designing and troubleshooting data architectures. Ability to think strategically and plan for long-term data needs. Typical tools and technologies. Data modeling tools, Irwin, Lucidchart, Microsoft Visio. DBMS, SQL Server, Oracle, MySQL, PostgreSQL, MongoDB, Cassandra. Data warehousing, Amazon Redshift, Google BigQuery, Snowflake. ETL tools, Apache NiFi, Tailend, Informatica, SSIS. Big data technologies, Hadoop, Spark, Kafka. Cloud platforms, AWS, Azure, Google Cloud. Data governance tools, Calibra, Informatica data governance, Tailend data stewardship. Example workflow. Requirement gathering. Meet with business stakeholders to understand data needs and requirements. Define the scope and objectives of the data architecture. Data modeling. Create conceptual, logical, and physical data models. Ensure models align with business processes and performance requirements. Technology selection. Evaluate and select appropriate data technologies and tools. Consider factors such as scalability, performance, and cost. Data integration design. Design data integration solutions to consolidate data from various sources. Ensure data is accurate, consistent, and accessible. Implementation. Implement the data architecture, including databases, data warehouses, and data integration solutions. Collaborate with data engineers and other technical teams to ensure successful implementation. Testing and validation. Test data models, integration pipelines, and overall data architecture. Validate that the architecture meets business requirements and performance standards. Monitoring and optimization. Monitor the performance of the data architecture. Optimize data models and integration processes as needed. Governance and security. Implement data governance frameworks and security measures. Ensure data architecture complies with regulations and standards. Career path. Entry level. Start as a data analyst, data engineer, or database administrator. Gain experience in data modeling, database management, and data integration. Mid-level. Progress to a data architect role with more responsibilities and complex projects. Design and manage data architectures for larger and more sophisticated systems. Senior level. Advance to a senior data architect or lead data architect position. Oversee the design and implementation of enterprise-level data architectures. Specialization. Specialize in areas like big data architecture, cloud data architecture, or data governance. Develop deep expertise in chosen areas and become a subject matter expert. Management. Move into managerial roles such as Chief Data Architect or Director of Data Architecture. Lead teams of data architects and drive data strategy and initiatives for the organization. Then next. Machine Learning Engineer. Role of a machine learning engineer. Responsibilities. Model development. Design and develop machine learning models to solve specific business problems. Experiment with different algorithms and techniques to improve model performance. Data pre-processing. Clean, pre-process, and structure data for training and testing machine learning models. Handle missing values, outliers, and data normalization. Feature engineering. Create new features from raw data that can improve model performance. Select the most relevant features through techniques like feature selection and dimensionality reduction. Model training and evaluation. Train models on large data sets and evaluate their performance using metrics like accuracy, precision, recall, F1 score, ROC AUC, etc. Perform hyperparameter tuning to optimize model performance. Deployment and monitoring. Deploy machine learning models into production environments. Monitor models for performance, accuracy, and data drift, and retrain them as necessary. Scalability and optimization. Ensure models can scale to handle large volumes of data and high request rates. Optimize models for speed and efficiency. Collaboration with stakeholders. Work closely with data scientists, software engineers, and business stakeholders to understand requirements and deliver solutions. Communicate technical details and progress to non-technical stakeholders. Research and development. Stay updated with the latest advancements in machine learning and artificial intelligence. Experiment with new tools, techniques, and frameworks to enhance capabilities. Key skills. Programming languages. Proficiency in Python, R, Java, or C++ for implementing machine learning algorithms. Experience with libraries like TensorFlow, PyTorch, scikit-learn, and Keras. Machine learning algorithms. Deep understanding of various machine learning algorithms, such as regression, classification, clustering, and deep learning. Ability to select and implement appropriate algorithms for different problems. Data handling. Strong skills in data manipulation and analysis using tools like Pandas, NumPy, and SQL. Experience with big data tools like Hadoop, Spark, and distributed computing frameworks. Model deployment. Knowledge of deploying models using platforms like Docker, Kubernetes, and cloud services, AWS, Azure, Google Cloud. Experience with APIs and microservices for integrating machine learning models into applications. Mathematics and statistics. Solid foundation in linear algebra, calculus, probability, and statistics. Ability to apply mathematical concepts to model development and evaluation. Problem solving. Strong analytical and problem-solving skills for developing and debugging machine learning models. Ability to troubleshoot and resolve complex issues. Typical tools and technologies. Programming languages, Python, R, Java, C++. ML frameworks, TensorFlow, PyTorch, scikit-learn, Keras. Data manipulation, Pandas, NumPy, SQL. Big data tools, Hadoop, Spark. Deployment tools, Docker, Kubernetes, AWS, Azure, Google Cloud. Version control, Git, GitHub. Example workflow. Problem definition. Understand the business problem and define the machine learning objectives. Collaborate with stakeholders to gather requirements and set expectations. Data collection. Identify and collect data from relevant sources. Ensure data is representative of the problem and sufficient for modeling. Data pre-processing. Clean and pre-process the data, handling missing values, outliers, and normalization. Engineer new features and select the most relevant ones for modeling. Model development. Choose appropriate machine learning algorithms and frameworks. Train models on the prepared data and evaluate their performance using relevant metrics. Model evaluation and tuning. Assess model performance and perform hyperparameter tuning to improve results. Compare different models and select the best one for deployment. Deployment. Deploy the model into a production environment using tools like Docker and Kubernetes. Integrate the model into applications via APIs or microservices. Monitoring and maintenance. Continuously monitor model performance and retrain as necessary. Address data drift, model degradation, and other issues over time. Career path. Entry level. Start as a junior machine learning engineer or machine learning intern. Gain experience in data pre-processing, model development, and deployment. Mid-level. Progress to a machine learning engineer role with more responsibilities. Work on more complex projects and collaborate with cross-functional teams. Senior level. Advance to a senior machine learning engineer or lead machine learning engineer position. Mentor junior engineers and lead strategic machine learning initiatives. Specialization. Specialize in areas like natural language processing, NLP, computer vision, or deep learning. Develop expertise in specific industries or advanced machine learning techniques. Management. Move into managerial roles such as machine learning manager or director of machine learning. Lead teams of machine learning engineers and drive the AI strategy for the organization. Then next. Big data engineer. Role of a big data engineer. Responsibilities. Data pipeline development. Design, build, and maintain scalable data pipelines to process large volumes of data. Implement ETL, extract, transform, load, processes to move data from various sources to data storage systems. Data warehousing and storage. Manage and optimize data warehouses and storage solutions, such as Hadoop, Spark, and cloud-based data platforms. Ensure data is stored efficiently and securely. Data integration. Integrate data from multiple sources into a unified system for analysis and processing. Develop frameworks for real-time and batch data integration. Data processing and analysis. Implement data processing algorithms and frameworks for transforming and analyzing data. Perform data cleansing, aggregation, and transformation to prepare data for downstream applications. Performance optimization. Optimize data pipelines and processing workflows for performance, scalability, and reliability. Monitor system performance metrics and troubleshoot issues. Data security and compliance. Implement data security measures to protect sensitive information. Ensure data handling practices comply with regulations and organizational policies. Collaboration and communication. Work closely with data scientists, analysts, and other stakeholders to understand data requirements. Communicate technical solutions and recommendations to non-technical audiences. Key skills. Big data technologies. Proficiency in big data technologies such as Hadoop, Spark, Kafka, and HBase. Experience with distributed computing and parallel processing frameworks. Database systems. Knowledge of database systems like SQL, NoSQL, and new SQL databases. Familiarity with data warehousing solutions like Amazon Redshift, Google BigQuery, and Snowflake. Programming languages. Strong programming skills in languages such as Python, Java, Scala, or SQL. Ability to write efficient and scalable code for data processing and analysis. ETL and data integration. Experience with ETL tools and data integration techniques. Ability to design and implement robust data pipelines for batch and real-time processing. Cloud platforms. Understanding of cloud computing platforms such as AWS, Azure, or Google Cloud. Experience with deploying and managing big data solutions in cloud environments. Data modeling and architecture. Knowledge of data modeling techniques and best practices. Ability to design scalable and efficient data architectures. Problem solving. Strong analytical and problem-solving skills for troubleshooting and optimizing data pipelines. Ability to resolve complex technical challenges in a dynamic environment. Typical tools and technologies. Big data frameworks, Hadoop, Spark, Kafka, HBase. ETL tools, Apache NiFi, Tailend, Informatica, Apache Airflow. Cloud platforms, AWS, Azure, Google Cloud Platform. Data warehousing, Amazon Redshift, Google BigQuery, Snowflake. Programming languages, Python, Java, Scala, SQL. Database systems, MySQL, PostgreSQL, MongoDB, Cassandra. Example workflow. Data ingestion and collection. Collect data from various sources, including databases, APIs, and streaming platforms. Ensure data is captured and stored securely. Data processing and transformation. Cleanse, transform, and pre-process raw data using ETL processes. Apply data quality checks and validations. Data storage and management. Store processed data in appropriate data storage systems, example Hadoop, Spark, cloud-based solutions. Optimize data storage for performance and cost efficiency. Data integration and aggregation. Integrate data from multiple sources into a unified data repository. Aggregate and organize data for efficient access and analysis. Data analysis and reporting. Collaborate with data analysts and data scientists to provide access to structured data. Design and develop data pipelines for analytics and reporting purposes. Monitoring and maintenance. Monitor data pipelines and processing workflows for performance and reliability. Implement proactive measures to address potential issues and optimize system performance. Career path. Entry level. Start as a junior big data engineer or data engineer. Gain hands-on experience with big data technologies and data processing workflows. Mid-level. Progress to a big data engineer role with more responsibilities in designing and managing data pipelines. Work on larger scale projects and collaborate with cross-functional teams. Senior level. Advance to a senior big data engineer or lead big data engineer position. Lead big data initiatives, architect solutions, and mentor junior engineers. Specialization. Specialize in areas like real-time data processing, data streaming, or machine learning infrastructure. Develop deep expertise in specific big data technologies or industry domains. Management. Move into managerial roles such as Big Data Engineering Manager or Director of Big Data Engineering. Lead teams of big data engineers and drive big data strategy and initiatives for the organization. Then next. Data Governance Specialist. Role of a Data Governance Specialist. Responsibilities. Data Governance Framework. Develop, implement, and maintain data governance frameworks, policies, and procedures. Define data governance principles and standards to ensure data quality, integrity, and security. Data stewardship. Define data ownership and stewardship roles within the organization. Assign responsibilities for data management, quality, and compliance. Data quality management. Establish data quality standards and metrics. Monitor and enforce data quality through audits, checks, and controls. Metadata management. Manage metadata repositories and catalogs to ensure comprehensive data lineage and documentation. Establish standards for metadata capture, storage, and retrieval. Data privacy and compliance. Ensure compliance with data privacy regulations, example GDPR, CCPA, and industry standards. Implement policies and controls to protect sensitive data and manage access permissions. Data classification and life cycle. Classify data based on sensitivity, usage, and regulatory requirements. Define data retention policies and manage data throughout its life cycle. Data security. Collaborate with IT security teams to implement data security measures and protocols. Monitor data access, encryption, and anonymization practices. Training and awareness. Provide training and support to stakeholders on data governance policies and best practices. Foster a data-driven culture and promote awareness of data governance benefits. Key skills. Data governance principles. Deep understanding of data governance frameworks, principles, and best practices. Ability to develop and implement data governance strategies tailored to organizational needs. Regulatory knowledge. Familiarity with data privacy regulations, example GDPR, HIPAA, and compliance requirements. Experience in interpreting and applying regulatory guidelines to data governance practices. Data management tools. Proficiency in data management and governance tools such as Calibra, Informatica Data Governance, or IBM InfoSphere. Experience with metadata management, data cataloging, and data lineage tools. Communication and collaboration. Strong interpersonal skills and ability to collaborate with cross-functional teams. Effective communication skills to convey technical concepts to non-technical stakeholders. Problem solving. Analytical and problem-solving skills to identify data governance issues and propose solutions. Ability to address complex data management challenges and ensure compliance. Typical tools and technologies. Data governance tools, Calibra, Informatica Data Governance, IBM InfoSphere. Metadata management, Apache Atlas, Alation, Informatica Metadata Manager. Compliance and security, Varonis, SailPoint, CyberArk. Regulatory compliance, GDPR, CCPA, HIPAA. Data classification, Varonis Data Classification, Titus Data Classification. Example workflow. Data governance framework development. Define data governance objectives, scope, and governance bodies. Establish policies for data ownership, stewardship, and quality management. Metadata and data lineage management. Implement metadata repositories and data catalogs. Capture and document data lineage to track data origins and transformations. Data quality and compliance monitoring. Monitor data quality metrics and compliance with regulatory requirements. Conduct data audits and assessments to ensure adherence to data governance policies. Data privacy and security implementation. Implement data encryption, access controls, and anonymization techniques. Ensure compliance with data privacy regulations and industry standards. Training and awareness programs. Provide training sessions on data governance policies and procedures. Raise awareness among stakeholders about data governance benefits and best practices. Career path. Entry level. Start as a data governance analyst or data compliance officer. Learn foundational data governance principles and regulatory requirements. Mid-level. Progress to a data governance specialist or data privacy manager role. Gain experience in developing and implementing data governance frameworks. Senior level. Advance to a senior data governance specialist or data governance manager position. Lead strategic data governance initiatives and oversee implementation across the organization. Specialization. Specialize in areas such as regulatory compliance, data privacy, or metadata management. Develop expertise in specific industries or regulatory frameworks. Management. Move into managerial roles such as Director of Data Governance or Chief Data Officer. Lead teams and drive data governance strategy and initiatives at an organizational level. Then next. Data consultant. Role of a data consultant. Responsibilities. Data strategy development. Collaborate with stakeholders to understand business objectives and define data-driven strategies. Develop roadmaps for implementing data initiatives aligned with organizational goals. Data analysis and insights. Analyze complex data sets to extract meaningful insights and identify trends. Provide data-driven recommendations to improve business processes and performance. Data architecture and integration. Design and optimize data architectures, including databases, data warehouses, and data lakes. Integrate data from disparate sources to create unified views for analysis and reporting. Data governance and compliance. Establish data governance frameworks and policies to ensure data quality, security, and compliance. Implement procedures for data stewardship, metadata management, and regulatory adherence. Dashboard and reporting development. Develop interactive dashboards and reports to visualize key metrics and KPIs. Customize reporting solutions to meet specific business requirements and user needs. Technology evaluation and implementation. Evaluate and recommend data tools, platforms, and technologies based on business needs. Implement and configure data management systems, buy tools, and analytics software. Training and knowledge sharing. Conduct training sessions and workshops to educate stakeholders on data analytics best practices. Foster a data-driven culture within the organization and promote data literacy. Project management and collaboration. Lead data projects from inception to delivery, ensuring timelines and deliverables are met. Collaborate with cross-functional teams, including IT, business units, and external partners. Key skills. Analytical skills. Proficiency in data analysis techniques and statistical methods. Ability to interpret complex data sets and derive actionable insights. Technical proficiency. Knowledge of data management tools, example SQL, Python, R, and database systems. Experience with BI platforms, example Tableau, Power BI, and data visualization techniques. Business acumen. Understanding of industry trends, business processes, and challenges. Ability to translate business requirements into technical solutions and vice versa. Communication skills. Strong verbal and written communication skills to articulate technical concepts to non-technical audiences. Ability to influence stakeholders and build consensus around data-driven decisions. Problem-solving abilities. Creative problem-solving skills to address complex data issues and optimize solutions. Capability to troubleshoot technical challenges and implement effective resolutions. Typical tools and technologies. Data analysis, Python, R, SQL, Pandas, NumPy. Data visualization, Tableau, Power BI, ClickView, D3.js. Data management, MySQL, PostgreSQL, MongoDB, Hadoop, Spark. Data governance, Calibra, Informatica data governance, Apache Atlas. Cloud platforms, AWS, Azure, Google Cloud Platform. Example workflow. Discovery and requirements gathering. Meet with stakeholders to understand business objectives and data challenges. Define project scope, goals, and success criteria. Data assessment and analysis. Evaluate existing data sources, quality, and architecture. Perform data profiling and analysis to identify opportunities and gaps. Strategy development. Develop a data strategy roadmap outlining initiatives and milestones. Recommend technology solutions and implementation plans. Implementation and execution. Configure data management systems, buy tools, and analytics platforms. Integrate data sources and develop dashboards for reporting and analysis. Monitoring and optimization. Monitor data pipelines, performance metrics, and user feedback. Optimize solutions based on insights and continuous improvement. Training and support. Provide training sessions and workshops on data analytics tools and methodologies. Offer ongoing support and guidance to ensure successful adoption. Career path. Entry level. Start as a data analyst or junior data consultant. Gain experience in data analysis, visualization, and basic consulting skills. Mid-level. Progress to a data consultant role with broader responsibilities in strategy development and project management. Specialize in specific industries or domains, such as healthcare, finance, or retail. Senior level. Advance to a senior data consultant or lead consultant position. Lead complex projects, manage client relationships, and mentor junior consultants. Specialization. Specialize in areas like data governance, AI, and machine learning consulting, or cloud migration strategies. Develop expertise in emerging technologies and industry-specific challenges. Management. Move into managerial roles such as consulting manager or director of data consulting. Oversee consulting teams, drive business growth, and shape organizational strategy. Thanks for watching.